Welcome. A soccer team plays in a stadium which can hold 10,000 sports fans. Average attendance at recent matches has been 8,500 fans, each paying $15 for their ticket. A community survey indicated that attendance rises by 1,000 for each dollar the ticket price is lowered. Let's go ahead and find a function which models revenue with respect to ticket prices. I'm going to start by saying X equals the ticket price. And I'm going to call this function here T. And I know that we have been selling 8,500 tickets, oopsies, at $15 a ticket. Furthermore, we know that more tickets will be sold, so I'm adding here 1,000 more for each dollar ticket prices are lowered. And I'm going to add one more thing here. Technically, this is the ticket price discount. There we are. That looks better. And remember that revenue is going to be X T of X. So in this case, it'll serve me better to simplify first. This is 8,500 plus 15,000 minus 1,000 x. So this is, what is that? 15, 8.5, 23,500 minus 1,000 x. So xt of x is 23,500 x minus 1,000 x squared. So this is our revenue function. Next, this soccer team is interested in maximizing their profits from the games. Determine the ticket price, which will maximize the revenue from ticket sales. First, let's look at our revenue function again. From the previous part, that's equal to 23,500 x minus 1,000 x squared. Our leading coefficient is negative 1,000, which is less than 0, so we know this is a downward parabola. And this downward parabola will have a vertex that is a max. So let's go ahead and find the vertex. X is equal to negative b over 2a. So that's negative 23,500 divided by 2 times negative 1,000. And popping this into our calculator, you get 11.75. All right, so ticket prices should be set at $11.75 in order to potentially maximize profit. Excuse me, maximize revenue. Okay, what ticket price will cause this soccer team to earn zero revenue? Right off the top of my head, I can think of charging $0 for tickets will cause the soccer team to earn zero revenue. So now let's use math to determine if that's correct. Hint, it will be. And what other ticket price will cause revenue to be zero? So revenue, R of X, will be zero. Set up this equation with 23,500 X minus 1,000 X squared. And this is equal to 0. We can factor out 1,000 X from each, and we're left with 23.5 minus X equals 0. Using the zero factor property, I know that 1,000 X equals 0. And I also know that 23.5 minus X equals 0. This first one gives me a solution of 0. So, of course, charging $0 leads to no revenue. And now this one leads us to x equals 23.5. So potentially charging $23.50 leads to no revenue. Okay, let's write out an answer. Clearly, charging $0 yields no revenue. Additionally, charging $23.50 potentially yields no revenue. And you may be wondering, noticing I use the word potentially. Remember, this is just a model, it's not exact. So this will certainly lead to little to no revenue. Mathematically, it is no revenue, though. Please keep calm and math on.